Alright, so in this next tutorial we're going to now learn how to size a 2-pound system. Now when it comes to sizing a 2-pound system, we have to understand that we are going to be sizing not only the 2-pound system but also the low pressure side. So it makes a lot of sense to write out our table so we can keep track of the two systems when we go to size this. If you refer back to the first tutorial and understand how to size a low pressure system, you'll understand the steps that we need to take in order to size that low pressure system, and a lot of that is transferable over to this, but you'll find that it's actually a lot more simple than you would think from the get-go. So the first thing we need to do is we need to see where our low pressure system ends and our high pressure system begins. So if we look on our sketch, we can see from the meter we got a 2-pound system. All right, so it's coming from the utility at 2 psi. We're going through section C at 2 psi until we get to this symbol right here. This is a regulator, and what that's going to do is it's going to knock it from 2 psi down to inches water column, or 7 to 14. Okay, so essentially our low pressure system is this, our high pressure system is this side. So to be methodical, we'll start with the low pressure system. We want to size that side first. Now the drawing is exactly the same measurements as the original tutorial. So if you referred back to it, you would see that we have our 100,000 BTU furnace, 40,000 BTU water heater, and our 30,000 BTU fireplace. So again, we're going to go through those procedures in order to size our 2-pound system and our low pressure. So as before, we've established our sketch and we've got our measurements and our BTU loads. We've taken care of that already. We'll start on the low side. So our type of gas here is natural gas, as we see on our drawing here. We've indicated we're dealing with natural gas. So we can put NG. Type of pipe. Well, again, we have iron pipe. So we can put iron. Our system pressure, well, we're going to go, since we're sizing the low side first, we have on the low side of our regulator 7 to 14 inches water column. So we'll go 7 to 14 inches water column. Our pressure drop, again, I encourage that we go with the maximum pressure drop. And for 7 to 14 inches water column, if you recall on the table in the gas code, A2A, our maximum pressure drop is 1 inch water column. So we'll write that inside. Our table, as I just stated, is A.2A in the current gas code. And our longest measured run. Now this is where it differs from our original tutorial. We don't take our longest measured run from the meter in this case. What we want to do is we're going to go where our 7 to 14 inches water column begins in our particular system. And for us, that's right at the end of our regulator here. So if we add up our measurements from this point onward, we'll establish our longest measured run. We can quickly see that 5 feet here and 5 feet here is 10, 5 is 10, plus another 10 is 20. So we've established that this section here is our longest measured run. So we can put 10, 15, 20 as our longest measured run. We've established now where to look up our code zone. So if we refer to our table A2A, we come down our side here and we want the highest one. So we have 20, which is our total. Incidentally, if this were, say, 25, we would move to the highest next measurement. That's why you should write down high if you tend to forget, like some of us do, in your code book, so that you can remember, always go to the next highest. In this case, we're right on the money at 20. So this is our code zone. So what we'll do is we're going to put our pipe sections right below our table, and we'll go A, B, C. Okay, so pipe A, if we stick with our code zone of in 20, we have 100 and plus 40,000, so we have 140,000 BTU that we need to supply. We can see quickly that 140 is well within the 156,000 maximum that we can run on a half-inch piece of pipe. So pipe A will be half-inch. Pipe B, we have 30,000 BTU. Again, we're well within the 156, so he's also going to be half-inch pipe. So we've done our half-inch or low-pressure system, so we don't need to worry about him anymore. Now we can focus our attention on our 2-pound system. So let's go back and write in for our information purposes here. Type of gas, well, again, it's natural gas, the same. Iron pipe, we don't have a mix. Sometimes you would have copper or iron pipe mixed, but in this case it's all iron pipe. System pressure, well, we're 2 pound now, so we're going to be 2 pounds all the way through to our regulator because we're working on this side. So it's 2 psi. Our maximum pressure drop. Again, we want to go with the maximum pressure drop, and according to our table, we are allowed 1.5 inches of pressure drop. All right. Now, sizing table. The next sizing table that we have is A4A, and the reason is capacity of natural gas in thousands BTU for Schedule 40 pipe or plastic pipe, including fittings, for pressures of 2 psi based on a pressure drop of 1.5 psi. It's the maximum pressure drop. So this would be the correct table for us to use. So we'll write that in here. A.4A. Our longest measured run. So again, if we start at the meter, we're not going to take into account all the way back here as we did in the first tutorial. Our 2-pound system starts at the customer side of the meter and runs all the way to the regulator where it switches from 2 psi to 714 water column. So our longest measured run is 10 this way, and this little section here, it doesn't look so on the drawing, but is another 10 feet. So our length is 20. So longest measured run, 20 feet. If we look on our tables, we move down again, and because we're on an even number here, we can stick with 20. And at 2 psi, a half-inch piece of pipe will give us up to 1,222,000 BTU. Now, if we add up our total again, we have 100 plus a 40 plus 30. We got 170,000 BTU. More than adequate. We could go with half-inch. So for pipe C, we're going to put half-inch iron pipe. So again, our code zone, 20 on that one, and our code zone, 20 on that one again. We've established our pipe sections and our sizing. Again, this table takes into account a reasonable amount of fittings, so we don't have to calculate any of that resistance, which we will be getting into when we size the 5-pound systems and 10-pound systems.